Okay, so today, we're diving into some pretty mind-bending stuff.
Oh, yeah.
We're talking about a computer that could solve a problem in 5 minutes.
5 minutes.
That would take the world's fastest supercomputer 10 septillion years to crack.
Wow.
That's the kind of power we're talking about with Google's new quantum chip Willow.
It's a completely different way of thinking about computation.
It is, and that's what we're going to unpack in this deep dive today.
Yeah.
What exactly is Willow, and why is this breakthrough so important? Why does this have the potential to revolutionize so many things?
It all starts with understanding the limits of our everyday computers,
Right.
the ones we use every day. They process information one step at a time, sequentially. It's kind of like trying to read a giant library book one word at a time.
Right, it gets the job done.
Yeah, you'll get there eventually.
And not very efficient.
Exactly. And for some problems, it would take longer than the entire lifespan of the universe to get an answer. And that's where quantum computing comes in. It uses the rules of quantum mechanics to do something amazing.
Okay.
Explore many possibilities at the same time.
So, like reading the entire library at once.
Yeah, you got it.
Okay.
Quantum computers use these things called qubits,
Right.
which can be in multiple states at the same time.
Okay.
Unlike the bits in our classical computers that can only be a 0 or a 1.
Right, a 0 or a 1.
Yeah.
So these qubits, they can be both at the same time.
Exactly. It's this idea of superposition that allows them to explore so many potential solutions all at the same time.
Okay, so more possibilities, faster results.
Yeah.
But I remember hearing that quantum computers were really prone to errors.
Yeah.
Is that still a problem?
That's been one of the biggest hurdles, and that's really where Willow's achievement is so significant.
Okay.
It's the first system to show what's called below threshold error correction.
Below threshold, what does that mean?
It means that as you add more qubits to the system,
Yeah.
the errors actually decrease exponentially.
Hmm.
For a long time, we thought more qubits just meant more errors.
Right, more problems.
Yeah, that would make large-scale quantum computers impossible.
Right.
But Willow's proving that not only is it possible,
Mm-hmm.
but it actually gets better as they scale up.
So they're not just building bigger quantum computers, they're building better quantum computers.
Exactly. And that's why this is being hailed as such a major milestone.
Okay, so let's get specific here. What exactly is Willow?
So Willow is Google's newest quantum processing unit,
Okay.
a physical chip.
Okay.
But instead of bits, it uses those qubits we talked about,
Right.
105 of them to be precise.
Wow.
But Google's not just focused on cramming as many qubits as possible.
Okay.
They're really emphasizing the quality and the performance of those qubits.
So it's not just about quantity, it's about how well they work together.
Precisely. Think of it like an orchestra.
Okay.
It's not enough to have a lot of instruments. You need them to be in tune and play in harmony.
Right, to make good music.
Yeah, exactly. Willow's designed to make those 105 qubits work together seamlessly.
Okay, I'm starting to get the picture.
Good.
But how do they test whether Willow's doing something a regular computer can't?
So they use something called a benchmark test.
Okay.
It's called random circuit sampling.
Random circuit sampling. Okay.
It's basically a problem that's impossible for a classical computer to solve, but a quantum computer can handle it easily.
Gotcha.
Think of it like a maze that would take you years to navigate, but someone with a bird's eye view could solve it in seconds.
Okay, so it's like Willow has that bird's eye view.
Exactly.
And it aced that test.
It aced it. Willow finished the test in under 5 minutes,
5 minutes.
while a classical supercomputer would need 10 septillion years.
That's just mind-boggling.
It really highlights the fact that we're not just talking about faster computers, we're talking about a whole new type of computation.
So how did Google achieve this breakthrough? What's so special about Willow's design?
Well, one key factor is they've optimized every component of the system for performance.
Okay.
It's not just about having lots of qubits, it's about how they interact, how stable they are, and how efficiently they can be controlled.
So like building a race car, where every part is engineered for speed and efficiency.
That's a great analogy, and one of the things they focused on is called T1 time.
T1 time.
It's a measure of how long a qubit can maintain its quantum state,
Okay.
that delicate superposition that makes quantum computation possible.
So longer T1 time basically means more stable qubits.
Exactly.
Right.
And Willow's achieved T1 times of almost 100 microseconds.
Wow.
That's 5 times longer than their previous generation of chips.
Okay, so we've got more qubits, lower error rates, longer T1 times. It seems like they've really cracked the code on building a stable and powerful quantum computer.
They've definitely taken a massive leap forward, and it's opening up a whole new world of possibilities.
Yeah, this is incredible stuff.
It is.
This is pretty amazing stuff.
Yeah, it is.
We've got these super stable qubits, performing these calculations at speeds that are just like mind-blowing.
Yeah.
And they figured out how to keep the errors under control.
Right.
So what's next? Like, what can we actually do with this power?
That's the exciting part. Google's ultimate goal is what they call useful beyond classical computation.
Okay.
So solving real-world problems that are just impossible for classical computers.
So no more like waiting forever for software updates.
Well, it's a little more profound than that. Think about the experiments they've been doing.
Okay.
We talked about that random circuit sampling, right?
Mm-hmm.
Which proves they've got this raw power.
Right.
But it doesn't have like a practical application yet.
Okay.
They've also been doing simulations of other quantum systems, which is super interesting scientifically.
Yeah.
But still doable on classical computers.
Right.
Just takes a lot longer.
Okay. So the challenge is to find algorithms that can tap into that quantum power.
Exactly.
To solve problems that matter to us.
Yeah, problems that classical computers just can't crack.
Like, what kind of problems are we talking about here?
Well, imagine designing new drugs.
Okay.
By simulating how molecules interact at the quantum level.
So no more trial and error. We could just create like perfectly targeted medicine.
Exactly. Or how about designing materials with specific properties?
Okay.
Like superconductivity or extreme strength.
So lighter, stronger materials for building stuff.
Exactly. Things like batteries that last for days instead of hours.
I'm starting to see why this is such a big deal.
Yeah, and think about the potential impact on energy.
Okay.
Quantum computers could help us design better solar panels, develop new catalysts for clean energy.
Wow.
Maybe even crack the code on fusion energy.
Which would be a game changer.
Totally a game changer for clean, sustainable power.
Yeah, it sounds like quantum computing could really help us tackle some of the biggest challenges that we face.
It really could, and let's not forget about artificial intelligence.
AI.
Quantum machine learning could lead to AI that's exponentially more powerful.
Okay.
Capable of analyzing these huge data sets and finding patterns that we could never see.
So AI that can help us understand things like climate change and maybe even develop new solutions.
Absolutely. Or it could lead to breakthroughs in personalized medicine. Predicting and preventing diseases before they even develop.
Okay, this all sounds incredibly promising.
It is.
But are there any downsides to this kind of power?
It's important to acknowledge that any powerful technology comes with potential risks. We need to make sure that quantum computing is developed and used responsibly.
Right, ethically.
Exactly, with, careful consideration of its ethical implications.
It's not just about the technology itself, but how we use it.
Right.
And the impact it has on society.
Yeah, that's a really crucial point.
So how can people listening learn more about quantum computing and stay up to date? It all sounds so complex.
The good news is Google's made a lot of resources available.
Okay.
They've got open source quantum software tools, educational materials, and even a course on Coursera dedicated to quantum error correction.
That's amazing.
It is.
So anyone can learn about this.
Yeah, even if you don't have a technical background.
And even if you don't want to get into all those details.
Yeah.
Just having a basic understanding.
Yeah, just a general idea.
Can really help you understand the future.
Exactly. It's like having a glimpse into what's coming.
Yeah. Speaking of the future, what's next for Google's quantum computing efforts? Where do they go from here?
Well, their focus now is on developing those useful beyond classical algorithms that we talked about.
So going from proof of concept to actually putting this to work.
Exactly. They've laid the groundwork with Willow. Yeah. They've shown us the power and the reliability. Now it's time to use it to create real solutions.
It's like they've built this incredible machine.
Yeah.
And now it's time to figure out all the amazing things it can do.
Exactly. And they're encouraging collaboration. They're inviting everyone to join them on this journey.
That's great. It feels like we're on the cusp of something huge.
We are.
A whole new era of computing.
Yeah.
But before we get too carried away with the future, let's just take a moment to appreciate what they've achieved with Willow.
Okay.
It's a pretty big deal.
It's a huge deal.
Especially those achievements in error correction and performance.
Yeah.
It's paving the way for this future.
Yeah.
Where quantum computers are actually useful.
Exactly. And the fact that they've achieved that below threshold error correction, it's groundbreaking because it means as they build larger computers, those computers are going to be more reliable.
Not less.
Not less.
Yeah.
Which is something that just a few years ago seemed impossible.
This really feels like we're at the start of something incredible.
Oh, yeah.
And to think this all started with quantum mechanics.
Yeah, it's crazy.
You know, this idea that a particle can be in multiple states at the same time,
Yeah.
or that two particles can be linked across huge distances, it just blows my mind.
It really challenges how we think about the world.
It does.
But it's these weird quantum things
Yeah.
that are making this leap in computing possible.
It makes you wonder, you know, if quantum computers are using these principles,
Yeah.
are they like tapping into other realities?
Mm.
Some physicists even say that quantum computing could be happening in parallel universes.
Yeah, that's where things get really interesting. The way we understand quantum mechanics is still up for debate. But this idea that quantum computers could be messing with other universes or even making new ones
Yeah.
is a wild thought.
It is. It makes you question like everything.
Yeah.
You know, if these parallel universes are real, what are they like?
Yeah.
Are there other versions of us out there?
Who knows?
It's a lot to think about.
It really is. It highlights that with quantum computing, we're not just making a new technology.
Mm-hmm.
We're maybe opening up these totally new ways of understanding the universe.
And our place in it.
Exactly.
So as we wrap up this deep dive, I really want to encourage everyone listening to learn more about this stuff.
Yeah, definitely.
Check out Google's quantum software and resources.
Absolutely.
Dive into quantum mechanics.
Yeah.
Let your imagination run wild.
Yeah, who knows? Maybe you'll be the one to make the next big discovery.
Right, or unlock the secrets of the multiverse.
Now that would be something.
It would. Thanks for joining us on this deep dive into quantum computing.
It was my pleasure.
Until next time, keep diving deep.